Hi, we're on 5.2 and it's called Normal Distributions, Finding Probability. I am renaming it to how to use your calculator for finding probabilities. Okay, so I have some guidelines here and this is just calculator work entirely. Okay, so remember when we were finding a normal distribution, we used this normal CDF, which is second, zero, log, and then arrow down to normal CDF, okay? And remember what goes inside that set of parentheses is your A and your B are your interval. And normally what we were doing was finding the area to the left of the z-score after we had defined the z-score and then enter in the mean and then the standard deviation. Okay, so for a z-score entry, okay, so from the left, and this is what I'm talking about, okay, from the left, which is negative infinity, up to the z-score, this is what we put in, the negative 10,000 up to your z-score. So whatever this z-score is right here, is what goes in to the second value in the set of parentheses. Okay? And the third value is 0. That's your mean. It doesn't change. The last value is 1. That's your standard deviation. That doesn't change. Now, if we're looking for the probability to the right of a z-score, okay, we're looking for this value right here. Now, up to this point, we were having to find the z-score that was to the left, or the probability, excuse me. We were looking for the probability that was to the left of that z-score, and then saying 1 minus that left score equaled the right score. We are avoiding that now entirely. Okay, so when you open up the normal CDF for the normal distribution, this interval here, it's the same interval up here, but instead of starting at negative infinity, we're starting at the z-score and going forward to positive 10,000, okay? And then 0 is the mean, and 1 is the standard deviation. Write that down. Hopefully you were doing that while I was blabbering. Okay, now here is the new thing that we are going to be using. Hopefully, if all the information is given, then that's what we use, okay? This avoids finding z-scores all around. And we'll use the z-score method along with the raw score method in a couple of the examples, just so you can follow both. The raw score, you're still using your normal distribution, your normal CDF, so you'll open that up. Your interval is still from A to B. C is the mean and D is the standard deviation, but these values are given in the problem. Like say our interval is from negative 10,000 to 50. The mean is 35 with a standard deviation of 3. Okay? Those are the kind of numbers that we'll be looking for in the wording of some of these problems that allow us to use raw scores. So, going back to example 1 in the try it yourself, okay? It says the average speed of vehicles traveling on a stretch of highway is 67 miles per hour. So this is try it yourself 1. The mean is 67 with a standard deviation of 3.5. A vehicle is selected at random. What is the probability that it is violating the speed limit of 70 miles per hour? So our interval is going to go from 70 to 10,000 because we're looking at, you've got your mean here of 67. He's right about here at 70, and we're looking for the probability that he is going greater. So we have to the right of that raw score of 70. So what we'll do is we'll open up the normal CDF, and our interval will be from 70 to 10,000. You could throw on as many zeros as you want. It doesn't matter. Our mean is 67, and our standard deviation is 3.5. So let's do that. Normal, 0, log, arrow down, enter. Then we're going to do 70, comma, 10,000, comma, 67, comma, and 3.5 equals. So this shaded area is 0.1957. Okay. Now what we're going to do is do the same thing with the z-score. Okay. So we still had the mean of 67, the standard deviation of 3.5, and we're looking for a z-score that is equitable, for lack of a better word, to the x value of 70. So the z-score is that value x minus your mean divided by your standard deviation. So our z-score is 70 minus 67 divided by 3.5, which gives us a z-score of, let's see, 70 minus 67 all divided by 3.5. That gives us a z-score of 0.8571. Okay, that's our z-score. Okay, and remember, we're looking for the value greater than the z-score of 0.8571, which corresponds to that x value of 70 miles per hour. Okay, so if we used z-scores, we'll open up normal CDF, and we will go from 0.8571, that's the z-score, to 10,000, a mean of 0, and a standard deviation of 1. That is going to give us that area to the right of the z-score. Again, we don't have to do the 1 minus the area to the left as long as we use the proper interval. So second, 0, log, arrow down, and here we're using z-scores instead of raw values. So I open up my normal distribution function, 0.8571, comma, 10,000, comma, 0, comma, 1, and I get not the same thing. Let me revisit this, please. Okay, I just realized, I'm so sorry, and I'm allowed to make mistakes too. Okay, if you're looking, if you're, and this is very important because I actually didn't realize it until this very second in talking through this problem. If you are using the z-score, you still have to do 1 minus the area to the left. Okay? You still have to do that. You don't have a choice because it will not come out right with the right probability if you don't. So we'll have to do it the right way. So the normal CDF will go from negative 10,000, which is to the left of that x value of 70, up to your z-score, and then 0, comma 1. So let's revisit. So open up the normal CDF, negative 10,000, comma, 0.8571, comma, 0, comma, 1. And there you get your area to the left. So in other words, we have an extra step here when we use, well, actually several steps, because when we're given this information here, in order to use the z-score method, you have to find the z-scores, get the area to the left of that z-score, and then subtract it from 1 in order to find the area to the right. If we used raw scores, it avoids all of that. So 1 minus 0.8043 is 0.1957. And that is what we got when we just entered in the raw score method. Okay, and again, I apologize, but it's a good thing I made that mistake, so you won't. I planned that. Now, example 2. We're going to use our calculator again for the raw values first, okay? So we'll use raw values first. And remember, the first two things are your interval, then your mean, then your standard deviation. So the problem says, a survey indicates that each trip to a supermarket is an average of 45 minutes with a standard deviation of 12 minutes. And what we're looking for is find the probability that the shopper will be in the store between 24 and 54 minutes. Okay, that is the first part. And then we'll also answer part 2 to that example. So the raw values will open up normal CDF. Our interval is 24 to 54 minutes with a mean of 45 and a standard deviation of 12. Now this will give you the exact number that you need to answer that question. Okay, so normal CDF, open it up, 24, comma, 54, comma, 45, comma, 12 equals, and you get 0.7333, meaning that 73.3% of shoppers are in that store, or let me rephrase, 73.3% of the 200 shoppers that enter the store are in there for 24 to 54 minutes, okay? Now, if we did the z-score, okay, you would use 0 for your mean, 1 for your standard deviation, and you would need to find the z-score. So say here is, if the mean is 45 minutes right here, okay, that would actually be our 0 if we're using the z-score method. 54 might be right here, and 24 might be right here. And we're looking for these values right here. So I'm just going to write 54 right here and 24 right here. If we were looking for the area in between, we'd first have to find the z-score that went with 54 as our upper bound on our interval. Then we'd also have to find the z-score that corresponds to 24 minutes. Take the area to the left of 54, which will be bigger than the area to the left of 24. Find the z-scores, plug it into your calculator, and then subtract the larger minus the smaller. Okay, which again is a whole lot more work than it needs to be. So now what we're going to do is, I'm going to erase this here, and we will do part 2 of that. So we are looking at more than 39 minutes, okay? So part 1 was between 24 and 54, And part 2 is greater than 39. So we'll open up. Because we're using raw values here, you don't need to worry about the 1 minus, okay? Your interval starts at 39 minutes, goes on into however many minutes. We're putting 10,000. Your mean is 45, and your standard deviation is 12. So entering that into the calculator, we will get 0.6915. Okay? In other words, about 69% of those shoppers are in the store more than 39 minutes. Okay? So it's more normal to be in the store between 24 and 54 minutes. And that's how you would use your calculator. So let's do the try it yourself 2. It says, what is the probability that, we'll use this. We're going to use the same page because it's the mean and the standard deviation. So the mean is still the same because we're referring to example 2's information. But this time, our interval is going to be between 33 and 60 minutes. Okay, remember, if you start with 33 minutes and you're given from 33 minutes to an hour, you're not going to go 33 to 1. If you're in minutes, an hour has to be stated in terms of minutes as well. So, normal CDF, your interval starts at 33, goes up to 60. These are raw values, remember, the mean and the standard deviation. So, hopefully we have become pros at this by now. And we find that that probability is 0.7357. Okay, and there you go. It doesn't get much more difficult than that. Okay, and example 3 just goes through telling us how to use our calculator to do that. So we're going to look at the, I'm trying to look at the try it yourself 3. Okay. We're looking up at example 3 where it says the mean triglyceride level is 134. So the mean is given as 134 with a standard deviation of 35. Okay, now for try it yourself 3, it says what is the probability that that person's level is between 100 and 150. Okay, so our interval is between 100 to 150. So when we enter in our normal CDF, it's our interval first from 100 to 150, the mean, and then the standard deviation. Again, very basic, easy stuff when you don't have to worry about doing it by hand. And that comes out to be 0.5105. There you go. Okay, now that is the end of 5.2.